All right, so we're on to the second part of today, and so if you're looking at your notes, we're on where it's the Cartesian coordinate system. And so if you um, look at that, Cartesian is named for a man named Descartes, and Descartes is right here. He's a French fella, and he did something that updated and kind of allowed us to do some mathematics that we had not done before, combining two essential elements. So I'm sure that you know that the Pythagorean theorem, way back thousands of years ago BC, we were using the Pythagorean theorem. He kind of put that together in that a squared plus b squared equals c squared format. And one thing that Descartes did was he applied the idea of taking a shape like what we have here and assigning numbers or coordinates to every point inside and outside of that shape. And so if I take this triangle and put it somewhere in this grid, I have a number line that goes along the horizontal and along the vertical. And so when you combine the geometric shapes and combine the real number lines, he came up with this coordinate grid, and that was kind of the birth of analytic geometry, where we can combine two huge fields, geometry and algebra. And so when we combine those, we get analytic geometry. So we can do things like the distance formula, which is an updated version in a sense, less than 400 years old, updated version of the Pythagorean theorem. And so let's go ahead and review how we're going to do that. We know that a squared plus b squared equals c squared is our distance formula. And so notice that if I come over here and I've got a point and I want to know what the distance is from this point to a second point out here, this point is going to have coordinates, x1 and y1. The point over here is going to have its own coordinates. We'll call that x2, and up here at y2. And notice that if I wanted to connect those 2 points, I could do so using a triangle, right? From this point to that, that's the distance that I want to know. If I go directly to the right, I'm going to get one side of a triangle, and if I go straight down, I'm going to get the other side. Notice that it makes a right triangle. And how far is this distance, right, from x1 to x2? Well, that distance can be measured along any number line using subtraction. So we could take x2 minus x1, and then how far is this distance out on the right? Well, that's the difference in the y values. So we could see that could be found by taking y2 minus y1. And once I have those two numbers, I am basically doing the Pythagorean theorem that we have up here above. I'm going to square a and b. So I take a, which on the bottom was x2 minus x1, squared plus b, which was the difference in the y values, squared. And that's going to equal c squared up here. Now, if this is my c value, I don't really want to know what c squared is. I want to know what c is. So at the end, I always have to take the square root. And that's our distance between 2 points. So let's go ahead and I'm going to do an example so that you can do one with your own numbers. So let's imagine over here at the right, or for any two given points, we'll just make a couple up. So we'll say we know the distance between over 2 and down 2, if that's A, and the distance between that and point B, which we're going to say is at -6, and we'll go up to, let's see, we'll just make up a number, we'll say 3. All right, so we could draw it out if we wanted to, but we could also just use the formula. I should probably move this up so I have a little room to simplify. So the difference between 2 and -6 right there is going to be -6 minus 2 squared. And then I want to have the difference between the y values, between 3 and -2. I'm going to put over here. So 3 minus a -2. And be careful when you're subtracting a negative because that becomes addition. So let's simplify a little bit. -6 minus 2 is going to be -8 squared. 3 minus a -2 becomes 3 plus 2. All right, remember a negative times a negative. Be careful on your calculator. If you don't use parentheses, it'll tell you that's -64, but we know negative times a negative is going to give us +64. 5 and 5 is 25 when we multiply, and then we add those together to get 89. And there's one of those irrational numbers. We could take the square root of that and find out approximately what that is. We know 9 times 9 is 81, and 10 times 10 is 100, so it's going to be 9 point something. So let's see if we could use our calculator to estimate that. We could just come up here to Google, square root of 89. 9.433, so we'll go 9.4 for our estimate. Awesome. And that's how we find distance between any 2 points. Let's look at, what if I want to use analytic geometry not just to find the distance between 2 points, but also the point in exactly the middle. Okay, we know how to find the exact middle if we're doing just a single set of numbers. So for example, if I have the number 4 and I have the number 15, and I want to know the number right in the middle, that's kind of like the average. So if I get a score of 4 one day and a score of 15, my average would be 4 plus 15 divided by 2, or 9.5. It's 5.5 more than the smaller one and 5.5 less than the bigger one. It's right in the middle. And that's exactly what we do if we want to find the middle point of 2 points where I have the x coordinates and the y coordinates. So what I'm going to do, let's take the same 2 points from up above. Let's make sure this doesn't move on us. So I'm going to take these 2 points that we used above here and move that down. Let's see if I can make that work. That didn't work. Try it again. So take these, take them and move them down here. And I want to find the midpoint of AB. Where's the point right in the middle? So the way I'm going to do that is I'm going to, just like before, when I found their distances, I had to group them together. I'm going to have to do that as well here. So the first thing I'm going to do is find what's the number right in between the x's. But to do that, I'm going to add them and divide by 2, just like I did with any 2 numbers. So 2 plus -6 over 2. That's going to be -4 divided by 2, or what is that? -2. That's exactly in the middle of 2 and -6. And then I'm going to have to, once I do all this, I'm going to have to find the middle of these 2 numbers, right in between -2 and 3. So -2 plus 3 divided by 2. I'm going to get 1 divided by 2, or 1/2 is exactly in the middle of -2 and 3. So it's 2.5 more than -2, and it's 2.5 less than 3. It's right in the middle of the 2. And we could draw that out if we wanted to see it. So go over 2 and down 1, 2, 3, 4, 5, 6. There's A. Go back 6, 1, 2, 3, 4, 5, 6, and up 3. There's B. We saw up above that it's about 9.4 units from A to B. That's the distance, about 9.4. And then the exact middle should be back -2 and down 1/2. So -2 and down 1/2, right there is our middle point. And we can see it, point to it there. Okay, right there is 9.4. Awesome. Okay, so I've got an example for you. Find the distance between EF, and I've given you coordinates right up here, and find the midpoint M of EF from up here, same 2 points. And then there's kind of a bonus question. If F is in the middle of another segment, EG, what would be the coordinates of G? So go ahead and stop and see if you can do those problems.